Hi everyone, I'm Sirish. I'm a second year ME student in VLSI from the batch of 2022, and I'm going to give you a small demo on IBM SPSS modeler. So, assuming that you have a training dataset and a testing dataset, and I'm going to tell you how to model it using IBM SPSS. So, you're going to open this. So now, as you can see, we've opened this, and now we just go to File, and this box pops up. So here what we want to do is create a new stream. So here I have selected create a new stream and then click on OK. So this is the stream. It's like a test bench, and wherein we place all our different uh, elements of this SPSS, which I'll be going through one by one. And using that, we can model our data using the different algorithms that are being present. So first of all, we'll go into the sources. So sources are like where we get the source of the data. So it may be in the form of a database, or the data may be in the form of a var file or an excel file, for instance. So here our data that we have is in the form of an excel file. So this is what we have to select. So I'm going to double click on this. So the Excel gets placed here. And so then we have different in record ops, we have different ways in which we can manipulate the data, like sorting, sampling, and all those things we can do using that. We won't be doing any of that. We'll just be working with the raw data. And then in field ops, we have the different setting the type of the data, like if the columns of the data are of the input type or the output type, or which is the target node, and things like that. So that is in the type. There are then other things, like you can have certain clauses or conditions for the data to be considered for a particular algorithm, or you can have like partitioning of the data, that is for validation. So we'll be using type and partition in our particular analysis. There are other things also here, and apart from that, we have graphs. So this will plot the data into different types. So you can have like a histogram or a multiplot or a time plot or other things like that. And in modeling, we have the different machine learning algorithms which we can use. Mostly these are all classification algorithms, but there are a few regression algorithms as well. So in our present uh, tutorial, I'll be covering a couple of algorithms. And then the output side, we can get the output. I mean, the output tested data, we can get it into a table, or we have certain statistics and analysis tabs here, which I'll be covering uh, in the further. Then we have the export. So after getting the output, if we want to export the output into an Excel file or a certain other file, we can do so using this. So this SPSS is a pretty straightforward, and it's very intuitive to work with. So as I've told you, the sources I've placed in Excel file. Before going into how to model this, I'll just show you the test and training data sets that I have. So here I have the SPSS demo folder, in which I have the training data and the test data, which are Excel files. So opening the training data, you can see that I have 2048 columns, 2048 rows, sorry, and in which I have 11 input columns, which is TSOI, NS, ND, NCH, IGS, all these 11 columns, and then the ion is my output column. So all these are inputs, and this is my output column. So using this, I'll have to train a model, and then get a model to which I can apply my test data and find the predicted ion value. So this is my training data set. So then this is my test data set. This is like some new data which will also have 11 data sets, and this is my TCAD value. I've obtained this data using TCAD. So this is like my TCAD value. or this is my known ion value. So here, due to the analysis, I need to get another predicted value column over here in the M row. So that I will get using the model which I create in SPSS. So let's get on with the modeling. So here I've placed the Excel file here. So now I have to double click on this. So here you can see that I can load a file here, which is import file. So I'll click on this. So I'll go to the desktop SPSS demo and I'll load in my training data set. Okay, so here if you can see here, it's showing that it cannot read the column names. So the thing about this is that sometimes there is some error with the XLSX files. So what we do is we click cancel. I'll go into this data set here and I'll save this as a XLS file. XLS. So this will save it into an older version of the same data set. So I'll save it into an XLS file. So this is the same thing, XLS, and I'll close this. And similarly for even the test data, I'll do the same thing. It's the test data, I'll save it as a XLS. So now I've done the same thing. There's no loss of data or anything here. I'll have the same thing. So okay, so let's get on with it. So I'm going to double click here. Now here I'll select the file type to be XLS and then I load in the training data. Click apply. Now here if you go to the type filter, you have all the different columns here. Now go to types and here you can see that all the roles have been assigned here. So if you click on read values, click OK, it will read the values, click apply and OK. Now what we have to do is set which of these as the input and which column is the output column. So for that I'll go to field ops, I'll go to type and drag it and place it, or you can double click it. So now we have to connect these two together. So for that, right click on this and click connect and just click left click on this. So this will get automatically connected now. So similarly, if you double click on this, you can see that it has, since it is connected, it will already get all these columns and see that the role is input for all of these. But the last one, ion, we want it to be the target or the output. So we have to click on it and click target and press apply and click OK. Now that we have this done, now what we have to do is we have to apply a machine learning algorithm to it to model it. So we go into modeling. So for example, I'll first do it with a simple regression. We have different algorithms here, say random trees, linear regression. This is linear regression, neural networks. Okay, we have SVM. So we have KNN also. Uh, K nearest neighbor. So most of these can be used like a regression algorithm. So here we click on regression. So double click on it. So this will automatically get connected. Now we have to double click on this so we can see what we are doing. So go to fields here. Now here we have to set which is the output and the input. So here click on use custom field assignments. Here in target, the target we want is ion, so click on that, and the input here is all these, so all these other 11 columns. So press Ctrl and then select all these columns except for ion and click apply. OK. Now we've got all these 11 columns over here and click apply and click OK. Now we can set other columns as well. For example, here you can see in analyze there is calculate predictor importance. This is really important if you want to rank the parameters as to which affects the on current more and which affects it, which of these 11 inputs affects it least. So this is a ticked already. So we can just explore more on these particular algorithms. You don't need to do anything over here. You can just click OK. Now what we have to do is we have to run this particular thing. So this will give us a model. So click on this and press the screen button and it will automatically give you a model. See, now that this is the model that has been generated, now if we open this particular model, we'll have different settings over here. We see that this is the predictor importance. So what this means is that TSOI affects the on current more. That is what is obtained here in this particular thing. The importance is zero point 0.3 and we have LGS affecting it next. So we can see that TOX GD affects it the least, affects the on current least, the change in this particular thing. So this is our predictor importance. We also get things like, since this is linear regression, we also get all different R square error, standard error estimate. This is of the just the training data. So, and this particular coefficients column is also very important if we are to find the coefficients of linear regression. So this is like ion is modeled as the weighted sum of all these particular are input variables, and the coefficients of each of these input variables is given in this particular column. So this is our linear regression model. So in linear regression, the important thing is this particular coefficients and also this predictor importance. So these are important. So now we go into testing this particular model. So for that, what we do is we have to now load the testing data here. So for that, I'll go into the sources again and double click on Excel. And now I have the Excel file here again. So now I'll have to again place a type data set here. I have type over here. Now I'll connect these two together, but I have to load the training data set here. So I'll double click this. Again, I'll change it to XLS, import this particular test data file here and click apply. Okay. Now if you go to type here, now here again you have to change the ion to target here and click read values so that the values are read. Click apply and OK. Now see that this is connected to this model, but the thing is we are testing this data. So it's like the test data is input into the model. So what you do is you right click on this, click connect and click on this. So it will ask you, it will tell that this particular thing already has a connection. So if you want to replace the connection, yes, we would like to replace it. So this connection gets replaced. So it's basically like this is the training data. We have created a model using it, and to this model we are inputting the test data. So now again we'll place one more type over here, just because uh, the output of this particular model now with the test data is another predicted output column, which is, since it is linear regression, I think it will be dollar $ion. So I'll just connect this to this guy, and if you double click on this, you can see that in these fields, apart from ion, we have dollar $e ion. So this dollar $e ion is our predicted value. So this ion value we had got it from TCAT, but this dollar ion, the dollar $e ion is the predicted value from the model. So that also will change it as the target, and click apply and OK. Now that we have both our ion and dollar $e ion, now we can make a comparison of both of them using the output tab. In this we can place a table wherein we can just compare it. We can just look the values side by side, or we can place the analysis tab. It will give you an analysis of all the thing which I'll show you, and we can also have a statistics tab here. Okay, and then if you want we can even place graphs. I'll show graphs in a while. So now if you press run, it will execute the entire thing once more. The mistake that I had done is there is no tab selected in the statistics tab. So we have to configure these tabs as well. So for statistics, yeah, here we have to examine two particular columns. So here I'll select ion and dollar $e ion because these are what we need to compare. So click on OK. So it will basically compute the count, mean, variance, and all these particular things for these two particular columns, and click apply. OK. And here also in analysis tab, we can like have performance evaluation and confidence figures and other things. We can do all those here. Okay. So actually, this is one way of doing it. But actually, before training this data into this ion, we can actually place one more here, which is the, if you go into the field ops, we have something called partition. So you can have a we can have a partition over here. So what partition does here is that, so what partition does here is that we can have like a cross validation effect here. So instead of directly training it, we can assign a certain partition of the training data to be a training data set and the rest of the data to be a testing data set. So it will divide the entire training data into a training data and test data, and it will perform cross validation over and over again so that it will give a better model, accurate model. So for example here, for the training data set, I'm giving, assigning say 80% of the sample as training partition and 20% of it as a testing partition. Now see that both of them should add up to 100%. So, and I can click apply and OK. So basically it will give you a better approximation of the model. So now I've, in the analysis tab, as I've told you, you can find different analysis here. I'll show you that. And in the table over here, this also I'll come to now. So if you just press run the whole thing, you can see that this model has run, and this, first we'll go to the table output. So this is the table output wherein we have the ion and $e ion. But the thing here is that the significant digits are only it's accurate to 3 places of decimal. So if you want to include more, uh, so we can close this again. So double click on this, and here if you go here to ion and $ion and set format. So standard decimal places here it's 3, so you can increase the number of decimal places. I'll just go with 6. Click OK. And for $eion also, I'll go to set format. I'll increase it to 6. So this number of decimal places increases, so you'll get a better approximation. Click apply and OK. Now if you run the entire thing, see that now you have a better relation here. And then here you can see for on comparison with this, the minimum error, maximum error between the predicted and the TCAD values, it will show the correlation of this. So, and other things is that this will show in the each column what is the minimum value, maximum value in ion, and similarly in $e ion as well. It will show, it will give you basically some stats. So this is how we model it. Now suppose you want to export this particular table into an Excel file. So for that you use export. So you double click on this. Sorry. You drag this Excel, go here, you connect it to this. If you double click on this, it will show the file name to where it has to be exported. So I just put it to XLS only. And here I'm going to change the to desktop SPSS demo, and here I'm going to change the name to output.xls. So here I have given the custom path. Click apply. OK. And also I had to show you the graphs. So this is like a graph board over here, wherein we can plot our different ion and $e ion and many other things. Like for example, here I want to plot ion. We get histogram dot plot and other things. We want to plot both of them. Press Control and select both. So we get a 2D plot here. So we can plot like a scatter plot, which is the most common plot here. So we can use this and click apply. Okay. And here now if we run the whole thing, we can get the entire result. So this is our scatter plot that we got. So this is the ion, this is the dollar ion. Since the particular plot may not be proper, we can even do this particular plotting work in other softwares like MATLAB, which gives you more customization power. So, and you can customize the axis as well with MATLAB. So here, since we have run this, it will be generated as an Excel file as an output. We can check in our demo folder. We have the output.xls file over here. Just click on this, see that the file has been exported, and we have this particular new column $e ion. So now that we have successfully achieved this modeling and we have got this predicted values, we can further go with this data into MATLAB for plotting these particular columns. So that is it with SPSS modeler. Thank you. Have a great day.